Carbon is a very important atom. It is one of the main ingredients found in every plant and animal on Earth. However, carbon can also be dangerous. When it builds up in the atmosphere, it contributes to global warming. This lesson will teach you more about how carbon moves around our planet. First, we need to establish where carbon is found. Large collections of carbon are called reservoirs. Why? Because a reservoir is where something is stored. If you went looking for every carbon atom on Earth, where would you find them? Over half of the carbon on our planet is found inside the rocks of the crust. This is considered a long-term reservoir because once carbon has become trapped in stone, it tends to stay there for a long time. 1/3 of the carbon on Earth is found inside the ocean. Carbon near the surface can cycle quickly, but carbon near the bottom can be trapped for thousands of years. 4% of Earth's carbon is found in fossil fuels. This includes coal, oil, and gasoline. Only 3% is left for everything else. There is carbon in the soil, and carbon in the air, and carbon inside plants and animals. The carbon in this last category is considered a short-term reservoir because carbon does not tend to stay in this form for very long. Like water, carbon comes in many forms and can be found in many different places. Let's start by looking at carbon dioxide in the air. When it rains, this carbon can be washed down into the ocean. Over time, some of it settles to the bottom, forming a layer of carbon-rich sediments. This carbon can be trapped down there for millions of years. But it isn't trapped forever. Because of tectonic motion, the oceanic crusts are slowly pushed towards the continents. When they meet, the heavier oceanic crust is forced down deep into the ground. The heat down there is so intense that the carbon layer melts and is squeezed back to the surface through volcanoes. Carbon dioxide is released back into the atmosphere where the cycle can start again. Because this cycle can take over 100 million years, it is called the long cycle. But it doesn't have to take that long. When living organisms get involved in the carbon cycle, it speeds things up significantly. Our atmosphere is made of many gases, but for now we will focus on 2 of them. Carbon dioxide is shown on the left, oxygen is on the right. Notice that these 2 molecules are very similar. The only difference is the extra carbon sandwiched in the middle. Let's watch what happens when a plant enters the cycle. First, carbon dioxide is absorbed by the leaves. It turns out that plants aren't interested in oxygen, so they spit it back out into the air. But what happened to the carbon atom? Good question. The plant kept it, because that is what plants are made of. Using carbon, the plant can grow bigger and taller than it was before. We say that the carbon has been locked inside the plant. This process continues over time. Carbon dioxide is absorbed, oxygen is released, and carbon is locked inside the plant as it continues to grow. Notice that the end result is a lot less carbon dioxide than we started with, and a lot more oxygen. This is good news for animals like us that need oxygen to breathe. But how can we get the carbon back? The answer is simple: fire. Whenever a plant is burned, the process reverses. Oxygen from the air unlocks the carbon inside the plant, and carbon dioxide is restored to the atmosphere. Remember that fossil fuels come from plants. This means that whenever power plants burn coal or cars burn gasoline, large quantities of carbon dioxide are being released into the atmosphere. Scientists worry because these gases are known to cause global warming. Earlier, I mentioned that 1/3 of Earth's carbon can be found in the ocean. Let's take a moment to look at what this carbon is up to. First, you need to realize that the oceans on Earth are not evenly heated. Tropical regions get very warm, and polar regions stay cold all year. Warm water is not able to absorb very much carbon dioxide. Also, warm water tends to rise. This keeps the carbon dioxide near to the surface at all times. But cold water is different. It is able to absorb considerably more carbon dioxide. Because of its density, cold water tends to sink, and it takes its carbon with it, deep to the bottom of the sea. As warm water from the tropics circulates towards the poles, it cools and fills with carbon dioxide from the atmosphere. Then it sinks, pumping more carbon into the depths below. This process is called the physical carbon pump. As our oceans grow warmer, it becomes harder for carbon to sink. This keeps too much carbon in the atmosphere, which triggers even warmer temperatures. Also, as carbon builds in warm surface waters, it makes the area more acidic. This can harm the plants and animals that live there. A second method for ocean circulation involves living creatures. Carbon dioxide from the air is absorbed by algae and other organisms that live in the sunlit regions at the surface. Over time, they grow and lock a lot of carbon inside their bodies. As these organisms die, they sink toward the ocean floor, taking the carbon in their bodies with them. This is called the biological carbon pump. Overall, the carbon cycle is a very delicate balance that makes life on Earth possible. As humans, we must be very careful not to throw this balance off.